Oh, hello everyone. My name is Hao Jiang. I'm an assistant professor in the Department of Biomedical Engineering at Lawrence Tech. So this is my talk presented to the Research Day event for the year 2021 at Lawrence Tech. The title of my presentation is Aerosol Sensor in Electronic Cigarettes for Monitoring Health Risks. These are battery-powered devices which have a tank to store e-liquid that contain nicotine. So this e-liquid can be heated by an atomizer driven by the power to generate an aerosol that contains very fine particles. And the users will be able to inhale these aerosols, which is kind of giving an experience similar with smoking traditional cigarettes. So currently, there are lots of concerns about the health risks and also problems in electronic cigarettes. For example, they contain too much nicotine, and also they can be causing lung diseases, and they are too appealing for teenagers, causing many high schoolers are starting doing vaping. And also there are very challenges for regulation because for the users, it is very difficult to avoid bad quality e-liquids or bad devices. So this problem and health risk concern basically saying that we need to do some significant innovation on electronic cigarettes. But unfortunately, in the existing electronic cigarette devices, there are so many limitations. Although almost all electronic cigarettes have microprocessors, but they are not smart enough. So they don't have enough sensors to provide you enough data. So they have very limited data, such as number of puffs, duration of the puff, the voltage applied to the atomizer, which is a heating module, and then the mass airflow, and that's it. And there's no alarms or no information if the user is using maybe a wrong e-liquid or maybe a good atomizer with a wrong operation. All these actions will generate harmful chemicals, but the device can never tell that. And the device will never be able to give the user any alarm or warning about such dangerous actions which can damage their health. So my proposed solution is I'm going to develop this aerosol quality sensor to enable what we call smart electronic cigarettes. And this idea is demonstrated in the schematic here. So the black-white part basically showing the components in the existing electronic cigarettes, including the tank for e-liquid, atomizer for heating the e-liquid, the batteries. So the e-liquid being heated by the atomizer to generate an aerosol. What is my innovation here are given by these color blocks, especially this big green block, which is what I call aerosol quality sensor assembly. This green block sensor assembly includes 3 sub-blocks. The big red one represents aerosol particle sensor, and the other 2 are the temperature sensor and also chemical sensor. Aerosol particle sensor can measure the aerosol particle size distribution. Temperature sensor can measure the temperature of the aerosol, and chemical sensor can measure the volatile organic compounds we call VOC, or other chemicals such as nicotine flavoring agents or whatever. So, and also this aerosol sensor, aerosol quality sensor assembly also has some peripheral components, such as a vibration motor and this display. Vibration motor can vibrate to give the user a warning about the danger in the aerosols detected. And also in the microcontroller board, we have a wireless module that can send the data to a wireless device such as smartphone to communicate data like that. So this is the prototype that I have built so far. So as you see here, this is pretty bulky. They include everything shown in the previous slide. This one is the electronic cigarette aerosol generation module. And inside here is our aerosol sensor assembly mounted across this aerosol delivery channel. This one is a temperature and VOC chemical sensor. And this relatively bigger one, this is the aerosol particle sensor. And both of these are connected to this microcontroller board, which has a ESP32 dual-core microprocessor with a wireless module inside and also color display on the side, and also a battery to power all these sensors. I also have an additional OLED display connected to the device to show the sensor data. So the housing is customly designed in SolidWorks and 3D printed. And this is the user face. user interface. So basically, this is how this device looks like. From the top view, I have my sensor data all shown here, and the mouse piece here, so the user can use this one to inhale the aerosol. We have other buttons for controlling the flaring of the aerosol and also to adjust the power for the atomizer. Also have a USB port at the bottom to charge the microcontroller board, and have this color display to show what they call aerosol quality parameters and the index. Also has other interface to show, for example, the settings of atomizers. And this device also has excellent data connectivity. So this device can communicate with computer through a USB cable, but this is optional. It doesn't need to operate with the USB cable connected. You can disconnect. And you can collect the data in the computer. And also, this device communicates, can be connected with a smartphone through the Bluetooth communication. So I have built an Android app. I call it Blue Devil Counter. This is an Android app built using MIT App Inventor. So this smart e-cigarette device send all the sensor data parameter to this smartphone, and then all the data are being displayed as you see here on this Blue Devil Counter app here. If there are dangerous aerosols being detected, then on this smartphone, a push notification will be given on screen, also with vibration on smartphone, saying that Blue Devil warning, hazardous aerosols being detected, stop vaping immediately. So I decided to introduce this concept called parameterized aerosol quality sensing. So what I'm gonna do, introduce will be like, for each puff, when the user takes in aerosol, this device should give a score about the aerosol quality. And this score will be a number from 0 to 100. So the higher score of this puff, meaning that you have a higher quality on this aerosol generated in this puff. And this score is called aerosol quality index, or we call it AQI. And this score is calculated from all the sensor data. Every time when the user is taking a puff, then this aerosol sensor assembly is going to measure the particle size distribution, the VOC, and also temperature. And then they are going to calculate the aerosol quality index, which is the AQI, and also whatever other parameters. Then these data will be displayed on the device, and also all the data parameters will also be sent to a smartphone wirelessly connected to this electronic cigarette. Then here is going to be a decision point. So based on the score of AQI, if this AQI, this score, is below the safety level, it means a bad aerosol. Then they're going to do two things. First of all, they're going to trigger the vibration motor on the electronic cigarette to warn the user about the danger, and also show it on the display as well. Then it will also trigger a push notification on the smartphone to warn the user about such danger as well. Then if the AQI score is high enough, means it's good quality aerosol, then nothing will happen. They just allow the user to continue using this aerosol without warning in that case. This is a kind of example about how this aerosol particle sensor behaves. So what you see on the left here, this is the data collected from a single puff in the electronic cigarette. This is a particle concentration versus the time on the horizontal axis. Each graph means particle size concentration for a specific particle size channels, from very small particle to very big particles. So these data are showing like this aerosol particle sensor is actually working really well, resolving all the data, but it has a limitation, like they cannot do well for the very small particles. So this artifact you see here, this is actually caused by the fact that the aerosol generated in electronic cigarettes have too high concentrations, which is difficult to be handled by the particle counter. So one promising solution is to dilute this aerosol before detection to reduce the concentration of particles. So I'm working for that one. I'm trying to solve that problem with my student, Brittany Whelan, who is a senior year student in BME department. So together we have another poster for this research day activity. It's called Adapter Design for Electronic Cigarettes with Controllable Dilution of Aerosols for Dynamic Light Scattering Measurements. For how to dilute aerosol, you can check this poster for the details. Also, this aerosol particle sensor will show us the particle mass concentration in terms of PM 1.0, PM 2.0, PM 10, working for different particle size ranges. In this work, I'm defining the score AQI, aerosol quality index, to be defined by this formula I invented, which is PM 2.5 minus PM 1.0 divided by 2 PM 1.10 minus PM 1.0 times 100. So what this formula means, this formula actually is equal to the mass percentage of smaller particles in the aerosols. So the higher concentration of smaller particles, meaning that this aerosol has a better quality. Therefore, it will give you a higher score of AQI. So this is the philosophy back in here. So this is kind of like preliminary test on this device. And in this test, what you see on the graph, these are aerosol particles counts for 4 different size channels. These channels are coming from very small particle size from channel 1 to very big particle on channel 4 in the micron size in channel 4 here. And then in this experiment, I am increasing the voltage, which is the power applied to the atomizer. The higher of the voltage, the stronger heating you are doing on the e-liquid. So here I'm increasing the voltage from 15 volts into 30 volts, 40 volts, and 60 volts. Then I'm collecting data when I'm inhaling these aerosols generated. So basically from here, you see the AQI, which is the score, aerosol quality score, is going to, as your power is increasing, you're going to decrease, you're going to find a decreasing score from 43 down to 40, down to 34, down to 33. Why this one decreased is because when you are increasing the heating, so the ratio of the larger particles will increase. And this is a trend which is also consistent with the finding by Floyd et al. Introduced in the previous slide. So basically the trend of this one is showing like when you find a lower AQI, that means you have higher ratio of larger particles in the aerosol. This one indicates probably an overheated e-liquid. Overheated e-liquid very often generate very harmful chemicals. That means it's going to give you higher risk for the health. So that means lower AQI means higher risk for the health. So the manufacturer recommended for this e-liquid is to be heated using 30 to 40 watts. And any voltage above 40 watts is actually considered to be misuse, that will overheat the liquid to generate harmful chemicals. So based on this AQI, I decided a safety level will be equal to 35. So that means if I get a score of AQI higher than 35, this aerosol will be considered as a safe aerosol to take in. If they detected the aerosol AQI below 35, then they will consider this aerosol to be a dangerous aerosol, and they should issue the warning and also the alarm to the user to stop vaping immediately. So this is kind of like a test on the device operations. So on here on the left, on the right, showing all the data interface being displayed on the device. The one on the left is when I'm doing proper usage on this electronic cigarettes, using a regular voltage of 30 volts. The one on the right, I am intentionally trying to misuse this device, giving it a very high voltage of 60 volts to overheat the aerosol, to overheat the e-liquid. From this preliminary test, it's basically saying this device is kind of working. It can tell from the proper usage on the electronic cigarette from a bad usage of this electronic cigarette. So such a kind of operation is able to help to minimize a health risk for the user to use electronic cigarettes. So this is kind of like the summary of my work. So first of all, in this work, I'm presenting a very novel electronic cigarette with this built-in aerosol quality sensor. And this is demonstrated for the first time. So this device in this talk is the first time to publish this device. And this is the world's first electronic cigarette of this kind. So this work is funded by College of Engineering seed grant at Lawrence Technological University. Thank you for your time for listening.